Okay, so what we're looking at doing here is creating a multi-view or orthogonal projection of an object, and we're going to use this block here to do it. So typically in third angle projection, which is the standard conventional way of representing multi-view objects in Australia and Europe, the front view is the view of the object that you choose to look at from the front. And I'm choosing this view, but it could be any view you want. So however you want to orientate your object, the base view is called the front view, and that's the main view. And it sits, you'll do it first, and it sits in a position. Then you'll look at the top view, which is looking from on top. So that's the green surfaces over here, and that blue surface, which you'll see from on top. And then from the base view, you generate your other view, which is your right-hand side view in this case. So that's looking at it from the direction I'm pointing with my finger, and you'll see the black shapes there. On top of that, you'll also see the hidden detail, which is dotted lines indicating hidden surfaces that you wouldn't normally see if you looked at the object purely in 2 dimensions. So let's start. I'm going to use tech drawing equipment. What you need is a sharpener so you can have a nice sharp pencil. The pencil needs to be sharp, otherwise you can't get accuracy. And you're going to need a set square like this. This is a 30-60 because it's a right angle here, and there's 60 degrees there and 30 degrees there. You can get other sorts, like 45 degrees are common, but I'm going to use a 30-60 at this point. The next thing I've got is a straight surface, which in this case is part of a drawing board. So this provides me with parallel lines that go up and down. And I can do without this. So there's another way of generating parallel lines, just for your sake. If you're sitting at home and you've got a ruler and you've got a set square, sorry about that, then you can use your ruler and your set square, line up your ruler on your set square like that, and you can move your set square by flowing it up and down. You can generate parallel lines like this. So line up to one line and then bring it down, and you can generate other lines as well like that. You can do the same thing to produce vertical shapes if you wanted to. You can make them slide along your edge and create vertical shapes that are parallel, vertical lines that are parallel like this as well. I'm going to use this wonderful little gadget here to help me, but you guys can do it in other ways if you choose. Okay, so let's start off. So the first thing that we want to do is create a base view, which will be our front view. I'm going to orientate the object like this, and I'm going to measure it, and I know that it's around about 100 millimeters on the base. So I'm going to start off with a simple construction line here. There it is there. Now, I'm not sure how clearly this is going to be able to be visible for you, so what I might do with you guys is, instead of using a pencil, I might try and use a pen, just so it's a bit clearer for you to see. I mean, you'll normally use a pencil, and because you can erase with a pencil quite easily. All right, so here's the projection line. It's just a straight line. I think you can see it there. All right, I'm going to measure 100 millimeters. So I'll start from, say, that point there. There's 40, and I'm going to measure 100, so it'll take me to 140. And that's 100 in case you don't believe me. Okay, 100 millimeters. From here, I'm going to create a rectangle shape. Rectangle box shape. So let's go up. I'm going to do a nice straight line. You'll see why I'm going to make this line so long very soon. Now I'm moving this along, keeping my set square nice and straight, and I'm going to make a box shape. So that represents the 2 sides that I can show. Next, how I want to show, how tall is this object? Well, it's going to be, measuring it here, it's about 58 millimeters tall. So I'll measure here 58 millimeters, there's 60 and there's 58, put a dot, measure this parallel line, and I'm going to do some line. You'll see why I do these long lines very soon. All right, now that's our shape sitting there. That's the outline. I'm going to now chop away this section here. So I know I've got to come in by 30 millimeters and across by 47 millimeters. So let's go down by 30 millimeters to here. I'll draw a little line here across, and again, it's just a construction line, so I'm not that worried if it's not exactly in the right spot. And how long did I say it would be? 47. Yes, you're right. There we are. 47. And now a vertical line across here, and I've got that stepped section that I just showed you. There's the stepped section here. 1 and 2, like that. Now, there's one more thing left to do, and that's that angle shape. That angle shape down here. How do we generate that? Well, let's assume that we can place an edge on here like this. It looks like it's 45 degrees. And were I to measure across there, I'd say if I measured in 11 millimeters by 11 millimeters down, I would have that step shape. So let's go 11 millimeters across from the edge to there, and 11 millimeters down to there. And I'm going to join those two lines at 45 degrees, which I'm pretty sure it is. And there is my step surface. Okay. Now I'm going to firm that in so you can see it a little bit more clearly, and so it'll make a lot more sense to you guys. So let's do this. So I'm going to go over the top here now. 1, 2, and because you're watching the video, it'll look a bit more clear. Now, if you were just doing this with a pencil, you'd be able to see it clearly, plus you wouldn't be drawing it like I am, I'm sure, would you? Now, firming this line produces an outline. Notice how I'm still leaving my construction lines in there. That's very important for me for later on. So there's my front view. So I'm going to label it front so you know what I'm talking about. Front view. Next, we're going to do a top view because the top view is always on the top. Now, I want to leave enough space so I can do some dimensioning. Now, let me just start with some dimensions, just so you guys are clear on what they look like. Dimensionings have a little leader line that starts off about 1 millimeter away from the edge of the object, doesn't quite touch it, goes out like this, and then you're going to find that the leader lines of the dimensions will come outside of your object. So you want to have them sitting outside your object, and then you'll have a dimensioning line that will join the two of them. Now, this is going to be a vertical dimension. So you see there's a small gap here, and there's a small gap there. The dimension will go across. And how high was it? Well, it was 58 millimeters. So I'm going to draw the 58 will sit on top of the dimensioning line, and I put two small arrowheads. That indicates the dimension between that surface here and down there. We might do this for the top over here as well. So I want to say, how long is the object? Well, a leader line will go 1 millimeter off the edge and up a little bit. Over here, the same thing, 1 millimeter off the edge and up a little bit till they're round about near each other. Draw the dimensioning line across. And remember how I told you that always the dimensions are sitting above the line. So that dimension there was 100 millimeters, and I'll sit it above the line. Now, let's suppose that we've got a situation like this where we've got a right angle surface. How do we dimension how long that is? Well, here's where my ruler can come in handy. If I set that ruler up at the correct angle like this, I can do a dimensioning line that comes off exactly at 90 degrees from there. And I'm going to do it leaving that small gap out to here. And remember, I'm keeping my dimensions away from the body of the drawing so that I don't interfere with the drawing itself. And what will that distance be? Well, I can use my ruler to determine it. It's going to be 15 millimeters. So I've dimensioned that little shape off the top there. Okay, so that's dimensioned now, approximately. We probably would need one more dimension, which I'll do a little bit later on, to be able to make this, and that would be the dimension from here to here. Let's move along now and create the top view. All right, the top view is going to look like this. So I'll move this down a little bit so you can see a bit more clearly. Top view will be looking straight down. So that's the front view. The top view looks on top of it. So to create the top view, I know it's going to be that width. So I'm all good with drawing a straight line all the way across the bottom to form this front edge that you see over here. So I'll make that one about there. There it is. And again, it's a projection line, so I can make it a bit longer if I want. Now, the next thing I need to know is how wide is the object. So let's measure it. All right, from 0 to here, it's 60 millimeters wide. So grab my ruler, track out carefully your 60 millimeters. And it's important here now to remember that when you're using a pencil, keep your pencil sharp, because a blunt pencil line can mean the difference between 1 or half a millimeter, which is quite substantial. Now, the next thing that I see, and this is the beauty of drawing your bottom, see this edge here, all right, on the top edge. How do I know the distance from here to here? Well, I don't really have to know it. If my base view is in position the way it is, I can simply transfer this dimension that I see here straight up there like that. And there it is. So that point and that point, this point and that point form these 4 vertices that you can see I'm pointing to here, just by drawing that line straight up. Now, I do have another line here going across the top. What's that line? Well, if I transfer this line straight up using my vertical measurement of my set square, like this, there is that vertical line. So that becomes that edge. And now I've got a circle to draw, and I'll tell you some more about the circle in a minute. But let's just say, find out where it is. The circle's going to have a center, which will be 25 millimeters in from the right edge, and it's going to be probably halfway across. And since that's 60, I'm going to make it 30. So 25 millimeters, we said, from this right-hand side edge. I'll make a little mark, and I'm going to draw my construction line straight up here. And actually what I'll do with it, I'll be a bit clever. I'm going to make this construction line go all the way across. Now I'm going to let you in on a secret. Because it's a construction line that goes through a circle, we're going to create a dash, long dash, short dash, long dash, short dash, long dash, short dash, long dash, and that indicates a center line or an axis. So whenever we have a center line or an axis, we're going to use a long dash, short dash. And that tells the people who are looking at your drawing that this is an axis of symmetry for some object. So it's the same way, long dash, short dash, long dash, short dash, long dash, short dash. And that's the center of my circle sitting right there. Now, if I had a small compass, I could measure the diameter of the circle. It's 10 millimeters. I don't really have a compass to do it with right now. So what I'm going to do is cheat a little bit, and I'm going to measure out and show you how to draw a quick circle. If you measure out the boundaries of your circle, like that, and you create a box, so a square shape. I'm just doing this freehand so you can see it. It doesn't have to be perfect, like this. And then you can draw the circle inside the box, doing one quadrant at a time. And it comes out looking okay, I think you'll agree. Now, very important that this hole goes all the way through the object like that. And when we have orthogonal drawings, we have X-ray vision like Superman, we can see the inside edges that are missing of that hole. And we indicate them using dotted lines. So they're going to be along these straight edges that I'm drawing here now as construction lines. And I'm going to show you the dotted lines. And this indicates to somebody that these edges exist, but they're not on the plane of view that you are looking at as you look at the front face of the object. They're sitting behind it. So they're indicated by dotted lines. Okay. Now we've completed, and I'm going to firm in the top view of the drawing. Firming it in is pretty kind of fun. You create your nice firm outline, and because you're only tracing, you don't have to be as careful as if you were doing it with fully. You don't have to worry about rubbing out as if you're doing it for the first time. So now I'm going to firm in these edges. One, there's my sloping edge top surface. Here comes my edge at the middle, which is causing the drop down the step. And now I've got my back edge sitting over here. There we go. Now there's my top view. So that's what it looks like from the top. I think you'll agree it's pretty correct. Now let's dimension this a little bit to help you. When you're doing dimensions that involve a, oh gee, I've lost a pen somewhere here. Okay, when you're doing a dimension that involves a circle, you still have a leader line, but instead of, you can, two ways of doing it. One is that you can create a dimensioning line, and I wish I could find my pen for you so I can do it properly. Here it is. You can create, if you have to go inside the object to do this leader line, then you have to do it. You just finish 1 millimeter short from the diameter line of the circle, like that. And then you can draw your line across here, your two arrows, and of course, where does your dimensioning goes? It goes on top, and it's 10 millimeters. There's another way of doing it, which is probably the more common way, which is neater, and that is you use an angle line coming off like this with a little arrow like that. And then you can indicate the dimension by putting a horizontal line across. You put the word R, which stands for radius, and the radius would be 5 because the diameter is 10. Now, if you wanted to indicate a diameter on a circle, it's a little bit easier, or differently. You can go all the way across through the center like that, and you indicate with two arrows pointing to the outside edge. So does that make sense? Can you see that? Yeah, I'll try and make it a bit bigger for you. So you've got your two arrows looking at your outside edge, and they indicate the diameter lines like that. Come all the way out to this end here, and then from here, the same story, create a horizontal line going across. And you use this symbol here, which is like a circle with a slash going through it. That indicates diameter, and the diameter is 10. So there's two ways that you can dimension circles. Now remember I told you the one dimension that we don't have is this dimension going across here. Well, let's fix this up now in our top drawing. So I'm going to draw my leader lines, starting from here, going upwards, starting 1 millimeter off the edge of the object, going upwards, and going across with a dimensioning line, and then we're going to create our two little arrowheads. Make them nice and neat. And the dimension across there was 47 millimeters. Now you don't need to put millimeters. It's understood that it's millimeters. That's a convention that's accepted on all ISO, International Standard Organization drawings. It'll be millimeters like that, yeah? So you're okay with doing that. Right, now let's do our last view of this multi-view projection. So we've done the front view. We should label the views. They should always be labeled. Here is the top view. There's the top view sitting there like that. And now we're going to look at it from the right-hand side, from this direction. So we'll be seeing something that looks like this. So let's decide where to start. Okay. I'm going to push it away a little distance because I want to do some dimensions, so don't push it up too close to your other views. We'll do a construction line going like that. How wide is the object? Well, the object here is, we said it was 58 millimeters wide. So from here, that point, I'm going to measure 58 millimeters. Like that, and I'm going to draw straight up, create my construction lines. Now again, I'm not too careful about having them stop at just the right spot. I know that there's going to be an edge, this edge here, there it is, which is that edge there. And when I look down across from the front view, that edge is going to appear as a straight line, directly in line with my front view. So the right-hand side view will have an edge directly in line with my front view. There it is there, and that's the edge here. So I'm just going to move straight across. You see how keeping the views lined up to each other really helps? Yeah. Now, the top here, I've got a top edge, which is that edge over here. And looking at the front view, it's the edge that's going down through the page. It's this edge here. That view sits, the edge sits right on top here. But then I've got another edge. See at the edge at the back here, which is that sloping surface? So this edge here, when I look from the front, is hidden from my view. But because we've got X-ray vision, it can't hide from us. So how do we show that edge? Well, you guessed it. We use the dotted lines, just like we did here with that circle. So the dotted lines are going to line up across here. They're going to be exactly along parallel to that, and here they come. Now, I'm going to dot them here with my light pen. And I'm now going to determine where this hole is. So we said that the hole from our dimensions here was going to be 10 millimeters diameter, but what we didn't indicate was how far the hole is from this right-hand edge. So we need to indicate that so the machinist or someone making it knows what that distance is. So because we're doing a 1-to-1 scale, so that means that one measurement of our object is the same as the measurement on our paper. I can measure across here and say, okay, well, it was going to be 25 millimeters. So I know that I'm going in 25s. Now let's indicate that on our drawing. How would we do that? Well, we could squash it up here and make it a little bit ugly and messy, but an elegant way of doing it would be to put the drawing, the dimension somewhere where it's not going to do too much damage and it's not getting in the way much. So I'm going to put it from here to here. So we'll go from that center line to this edge, like that. I'm just finishing just from 1 millimeter from the edge, do my two little arrows, and that's going to be 25 millimeters. Now, of course, the person doing this drawing will want to know what's the distance from the center. Is it halfway? So where would I put that dimension? Well, I could stuff it in here if I wanted to. I could push it on this drawing, or I could push it on this side over here where it's out of the way, and I think that's what I'm going to do. I'm going to use this center line here, and I'm going to use that edge, and I'm going to create my dimensioning line as a vertical line over here, there, and then I'm going to write the dimension. So first my little arrows, and the dimension was 30 millimeters. So that now specifies this point. It's 30 millimeters from this edge, 25 millimeters from that edge, and I know exactly where to drill my hole. So back down to my drawing over here, we know that the circle is going to be halfway. Oops, excuse me a second, I'll move this up for you. Let's make it a bit bigger for you so you can see what I'm doing a bit more clearly. So I'm going to know it's going to be halfway. So there's 60 millimeters, there's 30 millimeters halfway. And because it's the middle of a circle, remember we do that long dash, short dash line, which is called a center line. Long dash, short dash, long dash, short dash, long dash, short dash, long. Yeah, sick of me saying that. That indicates it's an axis. Now we know that our two hole is 10 millimeters, so that's 5 millimeters on either side, and we're going to have dotted lines all the way to that surface because the hole is only this deep. See it? It's only that deep. So our dotted lines stop at this edge here because this edge that I'm pointing at right there now, that edge is the same as this edge here. And that's where our dotted lines will stop. So here we go. We're going to do it now. And I'll drop out a little bit and do the dotted lines for you. Make them neat, make them accurate, make them precise. Well, we're just about done now. So I'll pan out a little bit. We'll trace this shape. And then we are almost finished with our orthogonal drawing. Now, the beautiful thing about orthogonal drawings, drawing them to a standard shape and size, is if you do it correctly, anybody, anywhere in the world will understand exactly what you're talking about without you having to say a word. And it means that they can create and carry out, and you can communicate with them precisely about what things mean, what objects are, and they can do it without even having to understand a word of the language that you're speaking. So now that object, with those dimensions, this object is completely defined. I could send this drawing to someone in Botswana and they could make it for me or cut it out for me exactly the shape that I want it. Or I could send it to Uzbekistan, or I could send it across to La Paz in Bolivia, or I could send it to New York, and anybody would understand exactly what that drawing means and how to make it. Isn't that good? All right, well, that's an orthogonal projection of a simple object. Thank you for listening and watching, and get back into your drawing.